Okay, so let's take a look at this one. I won't do all of it because I noticed in the ones above you know how to do the chi-square test statistic. However, this chart right here seems to be what's causing you problems, and both 3 and 4 are essentially the same. So, okay, so you're conducting a multinomial goodness of fit hypothesis test for the claim that all 5 categories are equally likely to be selected. Let's notice equally likely. That's very important. We're going to complete the table, report all answers correct to 3 decimal places. Okay, so since each of these categories are equally likely, we should expect, since there's 5 categories, that the probability of getting something in that category is 1 out of 5 for every single category. All right, since they're equally likely. So what we should be getting as our expected frequency is 1/5 of our total. So let's add up all the observed frequencies that there were. So I'll take 24 plus 11 plus 8 plus 9 plus 24. That's 76. Okay, so there were 76 observed frequencies altogether. What the expected frequency is 1/5 of that for every single one of them, because they're all equally likely. So I'm going to take 76 and divide it by 5, and that's 15.2. So this expected frequency should be 15.2. And that should be the same for every single one of these, since they're all equally likely. All right, now, our Pearson residual is just part of our chi-square test statistic process. All right, so you might remember, and maybe I'll take this to a word page. So remember in 1 and 2, as you found your chi-squared test statistic, you did the sum of O minus E squared over E. Well, for the Pearson residual, we're just doing this calculation without summarizing them all, each of them. We will, of course, summarize them for the second part of the problem, but the Pearson residual is just the separate piece. Okay, so we're going to have O minus E squared divided by E. If we go back here, we'll have 24 minus 15.2. Okay, so 24 minus 15.2 squared. Well, trying to square it. Squared. And then we'll divide that by 15.2. And that's going to give us 77.4 on top. 24 minus 15.2 squared. And then let's go ahead and divide it by the 15.2. And that's, I think it said 3 decimals. So 5.095, that's our Pearson residual. So we'll go back here. This is 5.095. And then you're going to do exactly the same thing to get the next Pearson residual. 11 minus 15.2 squared divided by 15.2 gives us the second Pearson residual, and so on. And then when you get ready to do your chi-square test statistic, all you've got to do is add up these Pearson residuals to give you what you need in your chi-squared.